In our last session, we learned about entropy and how it affects matter and energy differently. We saw that as time progresses, matter is moving from order to disorder, and energy is being transformed into less usable states. This understanding of entropy has a profound impact on how we understand time and our universe, since we can see it winding down like a watch. Since I mentioned the universe, let's define the term. Oxford Dictionary defines the universe as all existing matter and space considered as a whole. The American Heritage Dictionary defines it as all matter and energy, including the Earth, the galaxies, and the contents of intergalactic space, regarded as a whole. Simply put, the universe is the unimaginably vast ocean of space, time, matter, and energy that we find ourselves living in, and the smallest to the largest of things that we are aware of exist in its tremendous expanse. From the protons, electrons, and neutrons that make up all matter and store up our energy, to the stars, nebulae, and galaxies we can observe in space, all of these known forms of matter and energy are contained in our universe, and they are all subjected to the same inescapable entropy. That entropy affects all of the matter and energy that we have ever observed in our universe, and we can see that, just like a garment, the heavens and the earth are wearing out. This inescapable fact reveals that the universe had a beginning. Or more precisely, it reveals that the space, time, matter, and energy we are made of and live in, that we call the universe, had a beginning. The finite nature of the universe has also been confirmed in another way, based on the observations we have been able to perform with the Hubble Space Telescope. By looking at the light from distant stars, we can see if they're moving away from us or towards us or standing still. When they are moving away, the way we see their light is affected by what is called a redshift, in much the same way as a truck horn sounds when they pass by you at high speeds. If a truck was driving past you and they honked their horn, it would sound like this to you. That's because the sound waves are compressed or squished up when they're coming at you, but their sound waves are uncompressed and spread out as the truck heads away from you. In the same way, the light from an object can be measured to see if the light is shifting away or towards the red end of the spectrum, and that tells us if they're moving towards us or away from us. Since we have been tracking the visible motion of the universe relative to our position in it, we have seen that nearly all of the objects in space that we can observe are moving away from us at an always increasing speed. This means that the universe is expanding in all directions away from us, and that particular motion has caused physicists to conclude what entropy already suggested. The expansion of our universe points to the universe having a definite beginning in the past. This lines up with the constant decay of entropy that reveals the universe is winding down. And all of this confirms there was a beginning to space, time, matter, and energy as we know it. This is important because many philosophers and false religions have wrongly claimed that the universe was eternal and did not have a beginning. In stark contrast to that majority view, the Bible began by saying, "In the beginning, God created the heavens and the earth." Well, science has finally caught up to the Bible in this area because of the understanding of entropy in the expanding universe. Many in the scientific world now conclude there was a beginning. By the way, in this verse, the beginning represents time. Heaven represents space, and the earth represents matter. This means that the Bible actually records the moment when God created time, space, and matter with indescribable energy. All of this leads up to our first premise of what is called the Coulomb cosmological argument. And that first premise is, the universe began to exist. We have proof of this beginning through ancient historical documents, astronomy, physics, philosophy, and many other disciplines. And there are very few rational scientists left that will disagree with our first premise. It is commonly accepted, although reluctantly, that modern science has proven that space, time, matter, and energy, as we know it in our universe, had a beginning in the past. Although we would disagree with many scientists about how long ago that beginning was, we can agree that there was a beginning. We call it creation, but they refer to it as the Big Bang. For our next important premise, we need to consider, what is nothing? Surprisingly, what nothing is has become a very debated issue among those who are trying to deny God's existence, and we'll see why by the time we complete our argument today. Before our known universe existed, which is all that we can test, touch, taste, observe, experiment on, and accurately comment on in terms of the sciences, there would have been no space, no time, no matter, and no energy as we know it today, because that is what makes up our universe. Well, let's look at each one of those four things and define them better. Regarding space, Albert Einstein, with his theories of relativity and general relativity, has been proven accurate time after time over the last few decades, and his concept of space was not just an empty nothingness. He viewed space as a dimensional fabric that was affected by mass and interwoven with time. This means that space, in a sense, is the dimensional fabric that contains all of the matter and energy of the universe. Einstein believed that the mass of an object in the universe bends space and time like a weight on a stretched out cloth, and these curves in space and time directly affect the way objects interact with one another. Experimentation has conclusively proved that he was correct. Let's take a look at a video that explains what he found.
In 1905, Einstein published his theory of special relativity, which explored the link between space and time.
In Einstein's view, there isn't really a separate thing. There's space and then there's time. But there's just one thing, space-time, that we all live in.
He thought of this new space-time as a fabric weaving together space and time. In 1915, Einstein developed his theory of general relativity, which modified special relativity to include gravity and its effects on this fabric of space-time.
Welcome to the bouncy trampoline of gravity. We've taken our fabric of space-time, stretched it taut, and placed a heavy weight on it. See how it warps the fabric of space-time. When we roll the ball across the fabric, it magically seems to be drawn or attracted to the massive weight at the center.
General theory of relativity was a new theory of gravity, one that told us that gravity worked because space and time were curved in the presence of matter and could respond dynamically. Space itself could expand and contract in the presence of matter. A crazy but true idea.
Mass is a term used to describe the energy and matter that objects contain. The larger the mass of an object, the greater its distortion of the space-time fabric, the stronger the effects of gravity.
Gravity is not really a force. It's a fabric. It's a shape of space and time. And we just move along the curves of these shapes. And the act of doing so takes what would otherwise be a straight line to you and bends it into what you now describe as orbits, as trajectories, as pathways through the cosmos.
Einstein said not even light can escape the effects of gravity. As crazy as this sounds, proof conveniently arrived in 1919 in the form of an astronomically large experiment based on a solar eclipse.
General relativity said that if you look at a star on a path of light that goes right past the sun, you would see it shift just a little bit because of the gravity of the sun. So Arthur Eddington actually went out to test that theory during the solar eclipse of 1919 and actually photographed stars when the sun was blocked by the moon and you could see the stars behind it.
The ability to see objects that were actually behind the sun proved that objects could warp space-time. Einstein became a superstar overnight. He received the Nobel Prize in Physics in 1921.
This, by the way, is why the planets of our solar system, like Earth, orbit the sun. As we keep moving in our orbit, we keep our distance from the sun in space and ride around on the dent that it makes in space and time. If our orbit was to slow down too much, we would be drawn into the sun and burned up, like the slower moving marbles are moving into the center object. All we observe confirms space is like a fabric, much like it's shown here in this simplified demonstration. Interestingly, the Bible frequently refers to the fact that God stretched out the heavens. It even speaks of the heavens as a fabric, saying God clothes himself in light as with a garment and stretched out the heavens like a curtain. So what science has only recently learned, the Bible has said all along. The heavens are like a tightly stretched fabric, and God is the one who stretched them out. Now let's take a look at our second ingredient in our universe, which is time. As we saw in our video, space and time are very closely related, and they are often considered as woven together since the theory of relativity and general relativity were proven accurate. This is why you will hear many people refer to space-time as one word. Einstein even proposed, and later it was proven, that the same mass that bends space and creates gravity can also change how time passes. He also added that speed can have a direct effect on time. Einstein theorized that at the speed of light, time would stand still compared to those who are not moving at those high speeds. Here are several experiments that have proven his ideas.
$3 million at $2,300,000.
In 1971, Joe Haefele and Richard Keating put the theory to the test. They flew 4 atomic clocks around the world to compare the passage of time on an airplane with time on the ground. To see how time slows down with speed, they had to fly all the way around the world in the original experiment. Today's atomic clocks are more accurate, so the warping of time should be apparent even on an ordinary transatlantic flight.
Champagne for you, sir?
Yes, one for me and one for my friend.
Certainly. About 5 minutes past 4 local time, which is 5 minutes past 9 English time.
Einstein said time is that which is indicated by clock. I think I know what a clock is, therefore I think I know what time is.
Seem to be following an unbelievably constant track.
En route, they collected data from the pilot, then put it into Einstein's equations to predict the time change.
We have accumulated so far a change of 34 nanoseconds. And broadly speaking, it seems to confirm the original prediction. The clock will have gained somewhere between 37 and 40 nanoseconds when we land in about half an hour's time.
Suppose you would live for 100 years and you would spend your entire life on one of these aircraft flying around the world. You could expect to be younger than people who did not do that by about 1/10,000th of a second.
The UTC, USNO Master.
To measure exactly how much time changed relative to time on Earth, the clock on the airplane had been synchronized with the international standard at the start of the trip. Then it was compared to the same standard when it landed in the United States.
If we put other cables in here, and that changes by about...
The clock on the plane disagreed with the ones on the ground by 40 billionths of a second, just as Einstein predicted.
It's a navigational tool used by millions of people every day. With it, drivers know where they're going. Pilots fly planes more safely. It helps construction workers build straighter roads. Farmers plant fields more efficiently. Because of it, golfers choose better clubs. Skiers find faster ways down mountains. The uses for this innovative tool are virtually unlimited. It's called the Global Positioning System, better known as GPS.
So, exactly how does this incredible tool work?
So imagine you're on a field and you wanted to triangulate where you were because you know the positions of things in the distance that you can see. By measuring the direction to one object and another object, you can figure out where you would have to be in the field. Well, GPS is like that, but it's larger. It's in all three dimensions, not only where in the field, but how high, and also it's measuring time. You have 4 satellites. They're sending you signals, and you're measuring accurately where the satellite appears to be and when the signals were sent. And from that, you can figure out where you are on the Earth's surface.
The Global Positioning System is a network of over 30 satellites orbiting 20,000 kilometers above us. They move at a speed of 14,000 kilometers per hour. Each satellite follows one of 6 orbits, arranged so at least 4 satellites are visible from any point on Earth. The satellites constantly transmit signals, easily picked up by anyone with a GPS receiver. Each signal contains information on where the satellite is and what time the signal was sent. Using this information, the receiver calculates its distance from the satellite. This is done by multiplying the signal speed, the speed of light, by the time the signal travelled. The receiver then repeats this procedure for 3 more satellites, narrowing down its location to within a few meters.
To achieve this incredible accuracy, the timing information from the satellites must be extremely precise. So inside each GPS satellite is an atomic clock, the most accurate timing device ever created.
The GPS is so precise, it must take into account a number of subtle effects. Some of these are predicted by Einstein's theory of relativity, an idea that revolutionized our understanding of the universe. This theory includes special relativity and general relativity. Special relativity is a theory of space, time, and motion. Key to it is the fact that motion alters time. We see time running slower for a clock that's moving relative to us. Satellite-based GPS clocks are moving past us at 14,000 kilometers per hour. Because of special relativity, they gradually fall behind clocks in Earth-based receivers at a rate of 7 microseconds per day.
After Einstein formulated the theory of special relativity, he went further ahead and he proposed his theory of general relativity, which is not only a theory of space-time, but it's a gravitation theory.
Key to Einstein's theory of general relativity is the fact that gravity alters time. Clocks farther away from Earth, where gravity is weaker, run faster than clocks closer to Earth, where gravity is stronger. The GPS satellites are located 20,000 kilometers above Earth, where gravity is much weaker than on the surface. Due to general relativity, satellite clocks run 45 microseconds faster daily. When we combine the effects of special and general relativity, satellite clocks run 38 microseconds fast every day. This may not seem like much, but if uncorrected, all GPS measurements would be off by 11 kilometers daily.
The effects of relativity on Earth are normally 1 part in 10 billion, and so that's an incredibly small effect, and you're used to thinking you can forget it for most things. But when you're relying on how far light travels in a particular amount of time, if you're wrong by even microseconds, then the distances that you're getting wrong are that much larger.
To correct this error, engineers adjusted the atomic clocks inside the satellites, so on Earth they ran slow by 38 microseconds per day. This compensated for the effects of relativity and meant that, once in orbit, the clocks ran accurately, giving us the powerful tool we have today. So, as you see, what began as an abstract theory over 100 years ago is now used in everyday technology. Every time you use GPS, you're using relativity.
So science has demonstrated that space and time are related, and time is directly affected by mass just as space is. And we have also demonstrated that speed has an effect on time just as Einstein predicted. This means that so far, time and space as we know them would have began when the universe began, because they are expanding together now as the universe does. By the way, once again, science is only recently catching up to the Bible. The Bible has said for millennia that time flows differently for us than it does for God. The Bible explained relativity long before Einstein figured it out. Our third ingredient in our universe to consider is matter. Matter is currently defined as anything that has mass and exists in a solid, liquid, gas, or plasma form. Skipping the smallest items like quarks and other types of subatomic particles, we will say for today's purposes that the fundamental building blocks of all matter in the universe are called atoms. Atoms make up everything from flowers to galaxies or puppies to people. Every atom contains a central core called the nucleus. This central hub is made of particles called protons and neutrons. The nucleus is surrounded by mostly empty space except for very tiny particles called electrons that orbit the nucleus. These atoms are the basic building blocks of everything in the universe. Next, elements are the different types of atoms that we're aware of, and molecules are the result of elements that have joined together. Here we see that hydrogen and oxygen are combined to make a water molecule, for example. So atoms and their subatomic particles are what compose all matter in the universe. And there are so many atoms estimated to exist in our universe, we don't have a number for them. We simply say 1 with 79 zeros after it. Obviously, that is an unimaginable amount of matter. Now, our fourth basic ingredient in our universe to consider is energy. Energy is the capacity of a physical system to perform work. There are different forms of energy such as mechanical, thermal, chemical, electrical, electromagnetic, sound, or nuclear. Nuclear energy, for example, comes from fission or separation of the nucleus of the atom. By breaking the bonds that hold the protons and neutrons together, vast amounts of energy are released. This potential was discovered by Einstein's most famous equation, E equals mc squared. This equation means that the energy of an object is equal to its mass times the speed of light squared. At the most basic level, this revealed that there was lots and lots of energy stored in all matter. Once again, Einstein learned what the Bible already said. God's eternal power is visible in the things that He has made. We cannot even fathom how much energy or power is stored in our universe in just the matter we can see. Our sun, for example, compared to these other suns we have found, is so tiny we can barely see it. But to match our little sun's output, we would have to explode 90 billion hydrogen bombs every second. That gives us a taste of how much eternal power is truly revealed about God in our universe. So, now that we have discussed space, time, matter, and energy, and discovered how much energy and matter are in the known universe, let's go back to discussing what science now knows there was before the beginning, which was nothing. Can even one atom come out of nothing? If nothing had any energy or matter, it would cease to be nothing. But we can see from multiple lines of research that all that there is sprang into existence from nothing. So how does that happen? Where did the first atom come from? Where did the first joule, which is how we measure energy, come from? Where did space and time come from? These are the questions that science cannot fully answer. Science can only accurately deal with the testable, observable, and provable world around us, and we call that world the natural world or the universe. The natural world or universe is that space, time, matter, and energy that we now know sprang into existence at a finite point in the past. We can picture space, time, matter, and energy as we know them as inside the box we call nature. All that observable science can confirm resides inside of that box, and we can conclude from all of our observations that science cannot explain where all of it came from. But science can help us with one more important step. It can help us understand where the stuff in the box could not have come from based on how we observe all the stuff in nature work. In nature, could we ever expect to see a horse pop into existence from nothing? How about a bar of soap? Can even a post-it note appear from nowhere? Or does it always have to come from a factory who made it from paper, which came from a tree, which came from an older tree, and so on? Well, where did the first tree come from? Or, back to the first atom. Can anything ever be its own cause? No. Nothing we have ever observed in all of nature has ever caused itself to come into existence. We know this fundamental law from science within the box of nature, and that leads us to our second premise. Everything that begins to exist has a preceding cause. We never observed anything in nature begin to exist without a preceding cause. Your grandchildren cannot cause you to be born, and your children cannot either. Your parents who preceded you in time must have been the cause of your existence. And they had parents, who had parents, who had parents, and so on. This means that so far, we can summarize that the universe has a preceding cause. That means that before all that we can taste, touch, test, see, or experience physically in our universe came into being, something beyond nature was here prior to the universe as the preceding cause. The preceding cause of the universe must be beyond nature, meaning beyond space and time as the source of all matter and energy. And we can add to that, anything beyond nature is by definition supernatural. And this follows since the cause of nature had not only to precede nature, but also to transcend it as beyond nature. And these premises lead us to the conclusion the preceding cause of the universe must be supernatural. Our next step is to realize that the energy in the universe reveals that the supernatural and preceding cause of the universe must be at least equally as powerful as all of the energy that was created. We can say this because the laws of physics agree. You cannot get more energy out of a system than you put in. Our second premise here is this: the standard word used to describe a supernatural cause that precedes time and space, that has the power to cause the universe, is God. This is the historical definition of most cultures for the being called God. And these two premises lead to the conclusion: God is the supernatural, preceding cause of the universe, who is at least equally as powerful as the sum of the energy of the universe. So we have tried to lay out every premise that leads us to this final logical conclusion, so that our reasoning can be analyzed. But if all of the premises are true, I think we can reasonably agree with this logical conclusion. God acknowledges that his attributes were invisible, but he also demonstrated them in what he has made, so that even though we cannot observe him directly, we can inductively know that he exists. This means that this passage serves as a very serious warning to all who reject these basic inductive arguments that allow us to clearly see God's invisible attributes. Next week, as we continue, we will see that other facets of our universe help us to understand even more about God and his invisible attributes.